Okay, today we're going to be talking about section 4.8, which is complex numbers. Now, whenever we're calculating complex numbers, we start off with understanding how they exist or why they exist. So, the square root of 4. Whenever you're calculating the square root, what you are looking for is a number multiplied by itself that gives me 4. It must be the same exact number. So how do I come up with 4? I come up with 4 by simply taking 2 times 2. They are exactly the same number, so that means the square root of 4 is the number 2. That is the answer. However, if I'm taking the square root of -4, the way to obtain a negative outcome is meaning my signs must be opposite, which means I'm going to have -2 times +2. Those two numbers are not the same, which means I cannot calculate this. It is not possible. So what we do is we come up with another number system, and what we call this is the complex number system or the imaginary number system. This system exists to take the square root of a negative number. Square root, fourth root, sixth root, it's an even root. So this exists to take the even root of a negative number. Now, the form of a complex number is going to be a plus or minus bi. A is the real number and B is the imaginary number. Now, here's the biggest thing that your brain needs to know. I squared is equal to -1. So the way we're going to do this is we are simply going to calculate each of these individually. How do I go about that? I'm going to make this become -1 times 16. So if I make this -1 times 16, -1 is the same thing as I squared. So now I can go ahead and take the square root of each of those. That means I squared comes out as an I and 16 comes out as a 4, which gives you the answer 4i. Same thing over here for the square root of -9. So that's going to be -1 times 9. -1 is the same thing as I squared. And then if I take the square root of I squared, that gives me I. The square root of 9 gives me 3. So my answer is 3i. Okay? Now, with that being said, let's go ahead and go to the next concept here. The square root of -18. We are going to do this exactly the same way we did the other ones. So that's -1 times 18. And then this is going to be I squared. Now we need to break down 18. Now, if you remember previously, the way we did this is by simply doing factor finder. We found all the perfect square factors of 18, and the largest one was going to be 2 times 9. 9 is the perfect square, so that's what we're going to be using. So this is going to be 9 times 2. So then the square root of I squared is I, the square root of 9 is 3, to give me 3i square roots of 2. So it's doing everything we did before, whenever we did the square root page, but it's adding the -1 concept, which is the square root. Okay, the imaginary part. Same exact thing here. So this is going to be -1 times 48. What is -1? -1 is I squared. So we're going to come over here to our factor finder, and we're going to pop in 48. We're looking for the largest square, perfect square. The largest perfect square is going to be 3 and 16. So I have 3 times 16. The I squared pops out as an I. I can't do anything to 3, so it stays. The square root of 16 is 4. So this is going to be 4i square roots of 3. And you are done. Okay? So that's how you simplify anything with a negative underneath the radical that is an even root. Okay? So how do I graph them? So let's say I wanted to graph the point 2 plus 3i. Well, what your brain needs to understand is that the x-axis becomes the real axis, and then the y-axis becomes your imaginary axis. So from here, all you're going to do is go to the right 2 units on your real axis, then you're going to go up 1, 2, 3 units on your imaginary, and here's the point 2 plus 3i. And you can't really write that as an ordered pair, so I'm actually going to erase the ordered pair part and just put the 2 plus 3i. So if I wanted to graph, let's say -5 plus 3i, I'm going to go over -5 units, and then I'm going to go up 3 units. And that's going to put me right there, -5 plus 3i. Okay. If I wanted to graph, let's say -2 minus 6i, I'm going to go over -2, and I'm going to go down 6 to put me right here. -2 minus 6i. So that's really simple how to graph it. But let's go ahead and add them. Now, when you're adding complex numbers, all you're going to do is pretend that the I is a variable like x. So all I'm going to do here is I'm going to drop the parentheses because I'm not distributing anything in. I'm going to drop the parentheses here. And I'm going to simply combine like terms. 9 plus 23 is going to give you 32. And then 7 minus 21 is going to be 14i. And you're done. Okay? That's adding complex numbers. Subtracting complex numbers, well, I am not distributing anything into this first parenthesis, so I drop the parentheses. The second, I distribute the negative. And now I'm going to combine like terms. My like terms are going to be 6 minus 12. 6 minus 12 is going to give you a -6. Then I'm going to have 9i and 13i. 9i and 13i is going to give me a 22i. And then you are done. Okay? Now what about multiplying? Well, right now it's just kind of like the distributive property. So I'm going to distribute here, and this gives me a 12i, and I distribute here, this gives me a 21i squared. But you need to remember that I squared is equal to -1. So this is actually going to turn that into a plus 21. Why? Because that's going to be minus 21, a -21, sorry. So the double negative creates the positive, so we're going to rewrite this to give you 21 plus 12i. Okay. Keep going. The second one, these are two binomials attached by multiplication. So you're going to FOIL. First terms give you 12. Outer terms give you -28i. Inner terms give you 9i. And last terms give you minus 21i squared. Now, what did we know about I squared? I squared equals -1. So that changes that minus 21 into a plus 21. So I have 21 plus 12, which is going to give me 33. And -28 plus 9 is going to give me a simply, minus 19i. Trying to do too many things at one time here. Okay, next. Same thing as multiplying. So for multiplying, distribute, that gives me -3 minus 12i minus 15i minus 60i squared. Now, minus 60i squared turns into a plus 60. So 60 minus 3 is 57. -12 and -15 gives me a -27i. Okay. Next, denominators. Your denominators may not contain any radical expressions or imaginary numbers. If they do, you must eliminate them by multiplying by a radical expression or imaginary numbers. You always have to remember that I squared equals -1, and you always are going to multiply by a value of 1. But remember, 1 takes on infinitely many forms. 5 divided by 5 is 1, which is 6 divided by 6, which is x over x, which is x minus 5 over x minus 5. Those are all things that are equal to 1. So 1 takes on infinitely many forms. So what we're doing is we're going to multiply by whatever we need to eliminate the imaginary number in the bottom, okay? Now, 9 divided by 3 and 12 divided by 3 is possible to do. So we're going to simply simplify this. 9 divided by 3 is going to be a 3. 12 divided by 3 is going to be a 4i. And 3 divided by 3 is a 1 to give me an I. So what I did here is I simply reduced this. But I still have this ugly I in the bottom. I can't have that. So what my brain needs to remember is that I squared is equal to -1. So I need to turn the I into an I squared by multiplying by what I need to obtain an I squared. So I already have one I there, so I'm going to multiply by another one. Whatever you do to the bottom, you must do to the top. So I'm going to put parentheses around this, and I'm going to distribute. So that's 3i plus 4i squared over I squared. Okay, well, what is I squared? Well, we know I squared is -1, so this plus 4 is now I squared is going to turn into -4, and this I squared turns into -1. So what I have is -4 plus 3i, you always put the real number first, divided by -1, which is +4 minus 3i. And then you're done. Okay? Same exact thing, but this time, 5 is not divisible by 4, but 2 is. So we're not going to simplify, we're just going to deal with it. I don't care that the 4 is there, the -4. What I care about is the I. So I'm going to multiply by what I need to turn that I into an I squared. So that means I'm going to multiply by I. What you do to the bottom, you do to the top. Put parentheses here and distribute 5i minus 2i squared all over -4i squared. Now remember, what did I say I squared was? -1, so this minus 2i squared turns into +2, and the minus 4i squared turns into +4. So put the real number first. That's going to be 2 plus a 5i over 4. I no longer have an imaginary number in the bottom, and I am done. Keep going. Now, what we did before is we divided by just simply a monomial expression, which means I am just dividing by one term. There's no addition or subtraction at the bottom. Well, what happens when you're dividing by a complex number that has a real and an imaginary part to it? What this means is you have to multiply by the complex conjugate. The complex conjugate, if I have a plus bi, its conjugate, sorry, just did the wrong thing. Its conjugate is going to be the opposite of the imaginary number. You keep the real number, but you change the sign of the imaginary number from plus bi to minus bi. Now, the conjugate of -a minus bi means I keep the real number, but I change the imaginary from minus bi to plus bi. So let's keep doing that here so that you are aware. So I have 5 minus 7i. I keep the real, change the imaginary. I keep the real sign of -15. I change the plus 3i to minus 3i. I keep the real part of 16, and I change the minus 9i to plus 9i. What is the real part of the -27i? Well, guess what? There's a 0 there because there's nothing there. So the 0 stays, but it's not necessary, so I go ahead and change my sign to positive 21i. Those are the conjugates. Now, why is that important? Because if I give you a problem like this, you have to then be able to multiply by the conjugate from the top and the bottom. So what is the conjugate of my denominator of 3 plus 4i? The conjugate is going to be keep the real and change the sign of the imaginary, minus 4i. What to do to the bottom? You must do to the top. So go ahead and put parentheses around every single term, or every single binomial. So now what we have is we have 5 minus 2i times 3 minus 4i all over 3 plus 4i times 3 minus 4i. And you're simply going to FOIL the top, and you're going to simply FOIL the bottom. So 5 times 3 is 15. 5 times -4 is minus 20i. Inner gives me minus 6i. And last gives me plus 8i squared. All over. Now, whenever you multiply or FOIL conjugates, the inner and outer cancel. So all you have to do is the first, which is 9, and the last, which is minus 16i squared. That's all you have to do every time. So now you are going to change these. The plus 8i squared turns into minus 8, and the minus 16i squared turns into plus 16. So 15 minus 8 is going to give you a 7. Negative 20i and negative 6i is negative 26i. All over 9 plus 16, which is 25. Go ahead and check if you can reduce either direction. The answer to that is you cannot. So therefore, your answer is 7 minus 26i over 25. Now, in Math Excel, it may want you to rewrite this as 7 over 25 minus 26 over 25i. meaning it's going to want the real part of the number, which is the 7/25ths, and then it's going to want the imaginary part of the number, which is 26/25i. Okay? So be very careful and understand what the problem's asking you to do. Tonight's homework is 4-8 worksheet 1.